Okay, go ahead.
Yeah, I just, I'll be very brief. Just a real quick plug for the next one of these little get-togethers we have on a Wednesday night. 2 weeks from tonight, we have the unveiling. I'm really going to make it sound dramatic here. We have the unveiling of the PICUP capstone report, which is the culmination, not so much a final report on our PICUP project, but sort of a progress report, because we're still working on things. There's much yet to accomplish. So that's going to be 2 weeks from tonight, same time, same place, different channel probably. And it's several of the authors of the report will be making some brief comments, and then we'll have a chance to discuss it. So I also, in the announcement, in the events, I'm going to post, I didn't do this yet, but I'm going to post where you can get to the actual report so that you could, maybe read it ahead of time. Might be of interest to do that. So, okay, that's it. Karen, take her away.
Okay, well, great, thank you. So tonight we have with us Dr. Jennifer Delgado, who is an associate teaching professor at the University of Kansas. In that capacity, she's in charge of the lab courses. She has an interest in physics education research, although she tells me that what she's talking about tonight is not part of that research. It's just something she did in her class. And so I guess from there, I'll go ahead and let Jennifer take over.
Hi, yeah, I'm Jennifer, and thank you for that introduction, and thank you for inviting me to do this. I'm going to go and see if I can share my screen. Success, I think, right? Okay. Okay, so yeah, I'm happy to be here and talk about this. This is not really part of my research, and so that's why some of the stuff that you'll see, there's not a whole lot of, I would say, researchy kind of things to it. It's really just something I wanted to try with my class, and I'll talk about that here in a bit. So I come from a computational background. I got my PhD for astrophysics, doing computational work. I would blow up fake stars basically, and then model. They call them synthetic, but they're basically fake observations from these kind of events. And what I found from this is that a lot of the things that I had learned theoretically really became so much deeper to me as I had to actually implement them, because you can't, like if you do it wrong, you get terrible answers, garbage in, garbage out. So I really had to make sure that I was making sense of what I was doing. And I found coding was just a really nice way for me to have a deeper understanding of that. And that's part of why I've been interested in trying to include more computational things in my teaching. I went and actually met Karen, in 2019 at a PICUP event. I hadn't had a lot of opportunities to include it. Most of what I teach are more, I would say, survey courses. But this spring I've been teaching an introductory physics course, and I thought, well, here's my opportunity to maybe include some of this kind of thing. So the class I'm teaching is a algebra-based first semester physics course. These are not people who are going to go on to become physicists or engineers or astronomers. A lot of them are either in architecture or some type of bio track, like pre-med or pre-pharmacy or physical therapy. They're usually toward the end of their college careers, and they often tell me they are not excited about physics. They don't like math. So coming into this course is kind of something they have to do, not necessarily something they want to do. So a natural question would be, why care to try to get this population of students simulating things if they're not going to go on to do any sort of computational work? Like, this is not something that will likely necessarily benefit them in their career that they're having. But like I said, I found that I understood the physics of what I was doing and the astrophysics of what I was doing a lot better by doing some computational work. So I really wanted to try some stuff for the primary goal of deepening their physics knowledge and deepening their ability to solve problems within physics. Okay, so a big basically the big problem for me when I teach a course like this, and I've taught it before more than a couple of years ago. And what I saw and what some other instructors that I talked to about teaching this course have seen is that there's a lot of what I would call like one-step thinking. So they really want to be able to take like 2 numbers or 3 numbers and like just multiply or divide or add, just like shove some of these things into a calculator to get the answer. There's a lot of questions that sound like this. Do I just multiply these 2 number kind of things? Do I just do this? And this is very frustrating because when you go to try to solve problems, especially as you get to more interesting problems that aren't just like, oh, find the weight of an object with this mass here on Earth, you know, those things that can be done simply, you really do need to have a process that can help you kind of guide through these more complex problems. And what we want students to do, and this is something I've heard, this is something I kind of map out, but also I've heard from other professors here at KU, is you kind of want them to like write down relevant information, draw pictures, diagrams, figure out what they're after, try to maybe write down a few ways they could solve it, and then pick some sort of path that they may take. And then like what I really like is trying to get them to not just start plugging in numbers, but first, when they figure out what they're trying to solve for, rearrange things so that they have some type of basically equation that will tie what they're trying to find to all their variables, and they can reason through. And that's like, especially for this, trying to find reasonability of answers. Does it make sense if this gets bigger or smaller? So I bolded kind of everything that I see as a skill that I want them to develop so that they can be better problem solvers, that is tied to sort of computation, or that I think can be improved by moving towards more like computational like skills in solving physics. A picture and diagram, not so much, but I have an idea for that I'll talk about at the end. So I think for me, it's really just about wanting to get them to think more in a multi-step way with their problem solving, and using something computational like was my method to try to get that. So I want to point out that I think a lot of what PICUP does is more towards this simulation end, which is perfectly valid, and I would love to get there. But I think most of what I'm doing for my 114, my college college physics students is really down here. I would say the first beginning steps, which is sort of abstracting to the general, or learning how to like set up your code before you even get to say some of the fun, you know, like numerical techniques that you would use to solve a problem. So we're still basically sitting in the realm of the analytical and just understanding how things relate to each other. But for me, that's the first step. When you go to code something, you have to understand, like, you have to declare your variables, you have to understand how things are related. So yeah, I'm sort of down here at the very beginning. All right, so what did I actually have them do? I've had success in the past with forum posts, but only using a sort of specific structure. And I wanted to use forum post again for this, for a couple of reasons, but a big part of it is that about a quarter of my students are taking the class asynchronously. So they watch recorded lectures and then, you know, try to do the homework or try to take the tests. And for them, having any kind of interaction with other students would be really important. As I said before, I've had success with using these, but what I wanted them to do is work on these weekly homework assignments. I wasn't going to be able to, I didn't want to have them to buy something, and I wasn't going to be able to grade all of their work. I have about 270 students in the class. So I made weekly homework assignments for them that kind of draw from these big pool of questions, but I'm not grading it. Instead, what I'm having them do, and that they have to do each week, is they're making these forum posts where they pick one of the problems and they have to solve it and share this to the forum. So they have one post and one response to each week. I highly structure these things. So their forum posts have to have 3 parts to it. First, they had to give me basically their written step-by-step solution to the homework problem. So the very first step, and this is true, I feel, even in the coding world, you write everything down first. You plan out your code before you start coding so that you kind of have an idea. And it will change as you do it, obviously, but you have to have a plan before you just start typing stuff. And I wanted them to mimic that. And also this helps to develop the thing I really deeply care about, which is that problem solving sort of pathway and skill set. they had to then have a link to an Excel sheet, and this is the coding part of the assignment. So I have them build these like calculators out of Excel, and I will show one example of what I mean by this. But basically, once they reach a solution to their problem in terms of variables, they need to build a calculator into which you could put different values for those variables and then arrive at an answer. So they're kind of building this calculator to solve that problem. Finally, just to get them to interact with each other, they have to post a homework problem they may be struggling with and request for help from another student. They then, a couple days later, have to respond by checking the other student's calculator. So they're supposed to put in different variables and then hand check the answer to make sure that that is working. And then if they can, help them with their problem, either by saying, oh, someone else solved this, or helping them by writing out a solution. So that's what I made them do. They had to do one of these each week. The 1st and the 15th week were more just talking things. So this is really weeks 2 through 14. So they're just doing their last one this week. Right now, it's due tomorrow. So especially if you come from computational world, you may say, why Excel? I think it's kind of natural when we look at this level of student that you can understand why I'm not going to pick something like, like they're not going to do Fortran, but also not going to do Python. I've tried Python in the past, actually, with this level of student. I just did one little thing, and I noticed that they found it incredibly intimidating. They were really just, the idea of really coding was, I think, just psychologically, maybe it's just a big bar for them. But they're already using Excel. They use it in the labs for their tracking of data and plotting things. So they already have that. Excel, I think, comes off, like I said, a lot less intimidating. It doesn't really seem like you're coding or you're doing any kind of real computational work. And it is easier to learn to use, I would argue, from the outset than say like Python, which is not hard to learn, but it was just that extra step. I also would say that if you have any interest in doing anything like this, collaboration is actually probably a key part to it. One of the reasons is just practicality. I have almost 300 students. I cannot deeply grade all their work. So I wanted them to be able to put a check on each other. One of the things I found is that when students are having to turn in their work to just me, they are sometimes less worried about, oh, this is okay, but stupid. The professor's the only one who's going to see it. Than if their peers have to see their work. I've noticed that there's sometimes that peer pressure kind of motivates them to maybe do a little more, not always. But also I wanted them to do it collaboratively because I wanted them to take each other's work. Like I wanted them to create these calculators that could be generalized to different types of problems. And if they could recognize, hey, this solves this kind of problem, which is basically the same as this other problem, be able to just use that. Because recognizing the generalness or applicability of a thing I see as, and again, an important skill. And I also wanted them to be able to influence each other in terms of like, oh, I saw this way that they built their calculator. I really like that. I'm going to do something like that. Or if they didn't really understand what to be doing, hopefully seeing other people's work could help them improve. Okay, so I will say that these are the examples that I showed them in class. I basically spent, I'm going to say about 20 minutes kind of explaining what I wanted them to do in these Excel calculators. And I showed them some examples of ones I had built. They're not terribly fancy and they certainly don't look like real coding. But the idea is that there'll be some problem, they'll have known variables and they need to, and this I did specify, they need to give names to the variables. They need to have a space in which they can write the value of the variables, and they had to add units. So they have to have units, they have to have names. I said it might be useful to them if they write down ones they know and ones they don't know. Some people did do this, other people did not. I said it'd be a good idea if you could have, like, you show how you're converting between different kinds of units. And you certainly need to then finally at the end have this space that calculates the answer to your problem. So it's not shown on these, but these, they're built-in little functions, right? It's taking the values given by these other variables and calculating the thing that you're after. So this is what they're supposed to be building, or hopefully, and in some cases they did better than this, something like this, something that if you exchange these numbers for other numbers would give you still an answer. Okay, So I did ask permission to use student work. As I said, this is not research, but so I don't have like I don't have an IRB or anything. But so I asked a handful of students, hey, do you mind if I share some of your work? And a handful of them were gracious enough to let me show you some of what they did so I can give some examples of how this turned out. All right, so this is from a student. This is sort of towards the end. I ended up doing my structure my class in kind of a different way, and I don't want to spend a lot of time on it, but I spent a good half of the semester just talking about things in a one-dimensional sense before we moved on to doing vectors. So vectors actually came pretty late in the semester for us. We just did a lot of things with 1D forces and energy conservation before we moved on to vectors. So this is somebody who's been doing this for a while. This is somebody who's doing fairly well in the course. And what you're seeing are their handwritten work, so what they had to write out in terms of solving the problem, and then what they did with the Excel calculator. And what I really liked with this is that you can see how they're basically drawing the parallels. They're taking what they see or what they're trying to solve for, writing on the paper, and then just replicating that work. So you can even see here where they're trying to add these vectors. They're just writing down the components and that they're going to add the components, and then they say, yep, that's just what I need to do in my calculator. They also did a good job of, like making notes within their code about what the sort of limitations would be for their code. And I've kind of, they have more stuff over here that I've overlapped with their work. But this is, I would say, an example of what I would see as sort of success. I'm getting them to do the steps I want them to do in their problem solving, where they're identifying what the variables are, they're drawing a picture, they're showing me the steps for how they're going to solve this. And they've done this in a way so that if they see a problem that meets these conditions again, they could just plug in new variables and get an answer from this. So this is, I would say, an example of a good example of this. This one's also a really good example. This is actually pretty early on. So again, I said we did a lot of stuff 1D. There's still some confusion about dealing with kinetic energy. So instead of just writing the kinetic energy, they're still seeing things as changes. So they kind of have these extra steps, but they're still doing a lot of things that I see as useful. And one of the things that I thought was interesting that I didn't expect is that they started doing the same thing that I would do when I'm coding. So like if there are clear, like I'm making a new variable, in this case, they're trying to calculate the kinetic energy of this car. It's really an interim step. Like you could just leave the kinetic energy of the car in here, right? And then just resolve, like just write that in as a new big mega variable. But when I'm coding, sometimes I like, just for clarity's sake, to have those individual variables that are an identifiable thing, a thing that I could go and check and make sure, hey, did I do this right? And that's what some students did. I saw a handful, they started making these sort of interim variables that they would probably have calculated sort of by hand on paper. But this way they have the code calculator, the Excel calculator that shows them that sort of interim work. So they could do those sanity checks in between. And like I said, I saw a handful of students, especially students who are doing better in the course. And these forum posts aren't a huge part of their grade. Doing better in the course typically means they're doing better on the tests. But I saw a handful of ones starting to add these interim steps and label them so that they can basically track where things would have to go. Also, there's this one student in particular who got really good. I would say code documentation is really important, leaving yourself behind comments so you know what you're doing and why you're doing that. This student, I would say, is an example of, I didn't tell them to really do any of this. They sort of just grew into their own garden kind of thing. But they did this for almost all of theirs, labeling when they were doing like what the unit conversions would be, labeling the steps of what they're after, labeling like basically what equations they have. And they had this in several places where they would then start documenting so taking the analytical work that they had and then basically commenting through where in that analytical work and process they were to try to solve the problem. So I thought that was pretty cool because I didn't teach them this skill. They sort of just figured it out to do this. But I think moving forward, this would probably be something I would want to push for more students because I think it probably helped, but. So I don't know for sure that there are possible benefits, since the students who are doing well tend to do well on the coding assignments. It could just be that they're already going to do well anyway. So I don't know that doing these things lead to these benefits, which is why I've written possible benefits. And I'd certainly be interested in the future in trying to determine if that is doing what I think it's doing, or maybe it's just the writing steps down. But I have definitely seen for the students who are coming into class a significant improvement in terms of how they're approaching these problems. They are very good. So we do a lot of work in class. We spend about half our class time working on whiteboards. They have gotten very good about writing down all their variables and the values, like just basically declaring their variables at the beginning of their work. They are also better at basically leaving things in terms of variables until they're ready to plug in numbers. So that was a beginning of the semester, they want to just immediately put numbers in for everything, and then they run into this jumble of numbers that doesn't have meaning to them. But they have really transitioned away from that, the students that are attending class, and they're doing more of this. And they're also really good now about writing each step. This part's still a struggle. A lot of them want to jump ahead, but they have gotten better at that. And it could be it's just the practice of doing all this, but I have not seen that growth before in my 114 class when I taught it before. So I think it's at least possible that having to do this code is causing it. There's a chat thing, sorry. Okay, I'll get to it, sorry. Okay, it wasn't all sunshine and rainbows. I did have students, and it tended to be students who were doing poor in the class, have some troubles with trying to do this, some examples, and I didn't want to paste their work into this because that doesn't feel fair. But some students didn't, I don't think they got it for the first couple of weeks. So they would like paste their analytical work in as an image into the Excel sheet. Something I saw a lot of people doing is that they would do some of the work analytically and then not include that work on the actual Excel sheet. So they're not leaving it general, and I'll show you an example of that. I saw a lot of just hard coding things. So like if you were, say, supposed to multiply 4 by 2 because you're multiplying, say, a mass of 4 times a velocity of 2 meters per second, instead of like declaring mass as equaling 4 kilograms and declaring velocity as 2 meters per second, they would just type 4 times 2. And so they weren't like calling those cells as sort of variables. So that happens some, especially at the beginning. The biggest problem I would say is that there was little to no documentation of how they're checking each other's code. So I need to improve the scaffolding for that part of their forum post because this checking the code part, they're not doing that very proficiently. And then finally, some people just didn't do it. A lot of students did. The vast majority of them did this work, but sometimes people are just like, no, I don't want to do that. I should do that better. So this is part of what I mean by not including that work. So this student is trying to solve for the rotational energy for the cylinder and rotational kinetic energy, and they're taking this number that is going to be the angular speed in RPMs, and they're just converting to radians here in their analytical, or their explanation, but they don't include that anywhere in their code. They do give it here in terms of the radians per second, and actually the units, yeah, that happens, but they're not including this work here in their code. And I saw that a lot, where there would be parts where they don't, for some reason, they didn't want to include that in their steps. So that probably could use some work. Okay, I did towards the end because I was curious. So this was for me the first step of like, let's see, can I at least just get them to use Excel and to see things as general? And then I think I'm contractually obligated to report this, but KU was in this big basketball thing and like won the big basketball thing. I don't know anything about basketball, I'm really sorry. So they won the big basketball thing and a lot of my students were super excited. So I was like, well, this is the perfect opportunity to like try a little simulation. So I made up a little simulation. I gave them some of the basically starting pieces, and their job was to calculate, like just given regular old gravity, what they would expect the X and Y position of their basketball, given a height of a basketball player, initial angle of throw, and initial speed of throw. And they were offered this as extra credit because I had to have some kind of reward for the students who braved class. Like it was like the day after the big game. Not many people did this. About 15 to 18 students out of the almost 300 tried it. I only gave them a day too, so they only had a day to do this. But the ones who tried it, I got unsolicited positive feedback from about how much fun this was and how they wanted to do more of this kind of thing. So I think the next time I try this, I'm definitely going to start to include more of these things sooner, because and maybe I probably have to deal some with the scaffolding, because like the students who did it tended to be students who are already doing better in the class. And the students who were not always doing as best in the class, some of them tried it, but they definitely had a lot more difficulty with it. So it was kind of what I expected to happen. But I think adding, I think I've gotten to the point now where we could probably do more of this. I think that they're capable of it. It would just take more time. So what I'm going to try next, I want to scaffold those forum posts more. Like I said, some of them were still pretty confused a few weeks in. I need really a much better way for them to demonstrate effective checking of their code. So making that response basically stronger, adding more structure to it. Another thing I want to try, and I mentioned that drawing a picture of figure is important, but one of the things I want to try is having them graph variables versus each other. So like pick one of the variables in your equation and graph it versus your answer and talk about whether or not that makes sense. I think that may be important for kind of, because what I want is a sanity check of like, if this gets big, does it make sense that the other thing got bigger or smaller, whatever. And then that one simulation I tried, I thought it worked out pretty well for the ones that did it, but I'll definitely have to figure out how to fit it in, because it is going to take a lot more cost time to incorporate. One example is something that I may use in the future to sort of head into this, and they seem to like this. Was when I'm talking about simple harmonic oscillations, sort of making these numerical, graphs from position, velocity, and acceleration, to give them some sense of like, hey, how can I change these things to change the other things? This is mostly a demo at this point, but I think this could be an easy thing to incorporate into doing these sort of simple, this transition from just solving one problem into trying to make more for this level of course. So that's all I have. I do want to plug other people at the University of Kansas. Another teaching professor, Sarah Vush, is working very diligently with an undergraduate to start including this in our university level, so calculus-based classes. And I think she's going to try that out this summer. The new professor here at KU, Harwin Peelers, who does computational work for condensed matter, has done a whole lot for our undergraduate classical mechanics course. And I know he has lots of cool things to say about what he's done there, but I don't know how I would pick speakers, but I want to plug them because that and basketball, I guess, is what I'm required to talk about. But yeah, so thank you. And please let me know if you have any questions. Check that chat. Okay, so did you ask students to use define names so their formulas would look like their formula on paper? No, I did not. I did not do that. That would be a good thing to try. Yeah, because the formula is being hidden. That's part of why I like that code documentation. I thought that was a nice way of doing it, but that'd be another thing to try.
So how did you go about grading this?
I have a grader, and most of what it was graded on, honestly, was what I would call like a sniff test. We did some spot checking as well, but points were assigned for having given the analytical solution, like the step-by-step pen paper solution. Points were given for having a calculator where it wasn't immediately obvious that you like had just like one of those almost trouble list things. So like if it was, oh, it looked like it was reasonable, we got points for that. And then there was points for responding. So it's largely just based off of completion, but I would say like sniff test level completion. If I had fewer students, I think I could go more in depth with that. But surprisingly, I mean, like, so I went through and checked myself. Like I said, I did spot checking. And there are mistakes within things. Those definitely exist. The grader usually caught like those big ones. But they took it pretty seriously. Like I didn't have I didn't have a whole lot of, I would say, like just turn in something that looks like work to get the points. I think, but I don't know for sure. Part of that is just that they have to, their peers are going to see this and they know their peers are going to check it. And the peers did call them out too. I had instances of like, oh, I don't think your calculator is working for this. And they're generally pretty polite about that. But yeah, it was mostly completion basically.
So Gabriella has her hand raised.
Oh, I'm sorry, I have no idea how to, let's see. I
Hi,
can't see.
can I talk? I
Yeah.
like your activity very much. So I did something like using discussion board, something similar. Is this on a discussion board? Because as you said, when students turn work to us, they kind of, but when their peers see it, hopefully it's done better. That was
Yeah.
my feeling.
Yeah,
So
peer pressure. Yeah.
first of all, what percentage is this assignment in your
It's a very
grade?
small percentage. It's about 15% of their total course grade.
Okay, it's not so small. Okay, so it's 15%, and then once somebody figures out the formula, then are you a little bit worried then, how to say, they just take it, okay, you divide the numbers and that they go back in their mode of, okay, I got the way how it's going. Multiply these two, divide by the third or something.
Yeah, so one of the things that I can do for the Blackboard, which is going away, so I need to figure out how to do on Canvas, but like they can't see what anyone else has posted until they make their own post. And the homework question is one that they have to pick. So they probably could like work with another person and be like, we're both going to pick this problem. That could happen, but like they can't see other students' work just from the form until they themselves turn in some kind of work. I don't, is that answering your question? I'm not sure if
Yes, that's good. Yeah.
Yeah.
I'm just trying to figure out the logistics because the idea is beautiful, like kind to make sure that what the intention is going through them. And did you have the evaluation? Did they complain?
I haven't gotten an evaluation yet. No, I haven't gotten an evaluation. And surprisingly, I have gotten, I mean, maybe they're not willing to tell me to my face that they hate it, but they didn't complain at the beginning of the semester about doing it. I think honestly, because like with their homework, it lists for them like 10 problems, but they know they only have to do one of them and get that one right. And if they need to practice other ones, they can. And like I say in class, I force them into practicing their homework questions. I'm like, we're going to do these 3 kids, like, okay, I try not to say it like that, but so they, I think that they were more willing to do it because I wasn't asking them to do a whole bunch of problems. So they could really try to get a few of them right. And then I think too, they liked having access to other people's answers because they figured out about week 3. And I even got a question from a student. They're like, so wait, like I could just make a big Excel document with like all the answers that I find. And I said, yeah, you should do that. And they're like, oh yeah, I should do that. And so I think they saw value in being able to see other people's work. And then basically selfishly take that for their own future, like say testing needs, which I mean, I'm okay with. I'm gonna try to see if I can read. There was a comment. Perhaps rubric listings like listing unknowns and unknowns. Yeah, I think that's a good idea. I like that. Yep.
I have a
I'm so
question.
sorry. I can't see y'all's hands. Okay, I just
Okay.
closed it. I finally can see your hands. I'm so sorry.
That's okay.
Yes, please. Thank you.
Oh, Bill, do you want to go ahead?
I don't know. what
Sure. I wondered, had you heard anything from, you said that these classes are primarily like biology students and things like that. Have you heard anything from faculty or advisors in theirs where they would appreciate having their students learn this? Like, is there buy-in from their home departments at all?
No. So I haven't communicated with their home brands, and I'll be real honest, I'm in control of the labs, and our labs are so different from what everyone else's labs are. all communication I get is primarily like, why are your lab so weird? Like, why are you making us do this? So no, like I've gotten feedback from students about this not being so badish, but I have not heard from their home department. And I just started it this semester. Like I wanted to do something computational. It wasn't working for my survey courses, like my astronomy survey courses. And I was like, this is my opportunity. I'm going to see if I can get any, like just even that first step. So yeah, no, that'd be interesting. I should probably talk to folks there and see what they.
I have no idea what to expect. I'd just be curious if you had any feedback on that. I suspect this probably isn't at top of mind for a lot of those people, but I think it's a good experience for these students to learn how to think computationally. But sometimes we feel like we're putting a religion on someone else when we have these thoughts. Thank you very much.
I remember Anthony. Yeah, hi.
I did have a question about the simulations, but I think actually Charles has a question in the chat. I think he was asking about peers getting to choose which.
Yeah, no, the peers completely chose. So they could sift through until they found one that they're like, I want to answer this one because it doesn't look difficult. Totally, they could. And there is even possible for them to do duplicates. So sometimes people didn't get a response to their post because they'd chosen something, say, more challenging to do. But yeah, they just get to pick. I didn't force them to have particular peers. It was honestly a lot of what I was doing. I was like, I'm going to just try this thing and see what happens. But yeah, you could definitely probably structure it a lot more so that you're guaranteed a peer looking at your work. Or you have to look at 3 ones. I don't know. You could do some different things with it. Yeah.
I guess the question I was going to ask, like when you were talking about the simulations, like you had it in quotes. I guess like how did the simulation work? Was it like something that it looked kind of like Excel? Was it something like you coded in Excel and they just changed the numbers and saw what happened?
So what I did is so I basically just like I had, so I'm gonna share screen and go back. So like I have here where it's got like exposition, velocity, and acceleration. There I had like, there was a set of columns for X and a set of columns for Y. And I kind of showed them like the first sort of steps of like how you would go about to find, say, like, you know what the acceleration is for X and for Y, right? Like 0 and negative G. But so like, how do you go from that to then finding a velocity to finding a position across time? And I showed them that. And then I said, try this. I also gave them, I didn't show a picture of it, but I also said, try to add air resistance, which was just, a lot of them actually tried it. Nobody got it. But a lot of them tried it, which I was surprised by, because I kind of wanted it just to be like this extra, like, see who really wants it. But I was surprised by how many of them tried it. So yeah, I helped them with it. I would say I probably spent about 5 minutes sort of explaining some of that, and then I just said, try it if you want. Yeah. Yeah.
Are the problems that you give from a textbook?
Yes. So I use OpenStax because it's free. And OpenStax has some problems. I wrote some problems, and then I have examples from, say, other sources of problems. So I kind of just, I collected some problems to build into the pool. But yeah, I didn't use from one particular textbook. OpenStax probably has the biggest chunk of them, but yeah, I just didn't want them to have to buy anything.
But do they tend to copy the solution from somewhere?
Oh, I'm sure they do. Yeah, no, I'm sure they do. I know that I have cheating, especially because, like I said, a quarter of my students are online. I have caught out some of them cheating. So I'm sure, yeah, they had their handwritten solutions. I'm sure that happened in some cases. I would say the fact that not all of them have answers is probably indicative. But I didn't, like I said, I wrote some of the problems. Some of them came from their textbook. And I told them, like, all the OpenStax problems are online. The answers are there. Go look with them. But I didn't tell them the other sources that I had for some of the problems. And I purposely changed, like, if it'd be like a frog jumps, I'm like, well, now it's a tiger. Like, so, because that helps. But yeah, I'm sure cheating happened. Yeah.
Well, I'm saying this seems like a nice way to sort of force them to engage with the material, which is something I've been looking for.
If they can find an Excel notebook on Chegg, I'd be quite impressed. I'm sure it's out there by now. I don't have a Chegg account to check. I kind of want one because I know some of my lab reports are out there. How do you get the quizzes and tests? So I saw someone online talk about making these quizzes, like using, oh gosh, what's it called? Mail merge, where you could set up a Word document with a Google Doc with variables that then you could use an Excel sheet to fill in. And so everybody gets the same problem, but with different numbers. And I got obsessed with that. And that's how I did my quizzes and tests. So they have seven quizzes throughout the semester over each little section. And they all got their own copy of the test. They still cheated. I still found people who figured out how to cheat using that. But in order to cheat like that, they had to solve it in terms of variables first and then plug in the numbers. So small victory, even if they were still cheating with some of them. But yeah, that's their quizzes were 10 questions a piece, like just basically questions similar to what we'd either practice in class or on their homework, or sometimes a wild card. But yeah, I would think having to do the Excel calculation would make the problem of a known solution much less of an issue to translate. Yeah, so they have to understand some of it, hopefully. Using Porter, how do you know that somebody else did the quiz for the Proctor? So I used Gradescope. I don't know if you've all ever seen. So my tests would generate all these PDFs, like 200 something PDFs, and then I have a Google Drive, and their names are attached to it. So like you can get it to generate the test with their names on it. I know they're cheating. I should say my grader found the students who were cheating because they would write out their work and their words were the same. Every step was exactly the same. The only thing that's different is the numbers. So yeah, that was 2 students. There was another pair that we suspected, but it wasn't as identical. Yeah. There's always going to be cheating. It's unfortunate, but
Jennifer, I missed this. Is the class entirely asynchronous? Like there's no in-person component? Oh,
so biology begged us because there's some issue with their scheduling, and a good 60 of their students, with less than that, like 50 students, couldn't attend the course time that had already been set through like tradition or whatever. So most of the students they can attend asynchronously, and I set it up so they can either do through Zoom or come in person. And I get probably solidly 50 or 60 students in person each week. 50 or 60 have to do it asynchronously, and the rest, I maybe see them online, but a lot of times I just don't even see them. So there's some attendance issues there. But yeah, no. So some of them are asynchronous, some of us are synchronous Zoom, and some are synchronous in person. And some are just never there, I guess.
the reason I was asking is because I was wondering, like, were you interested in doing any kind of like coding activities where they would like collaborate in person, or is it like purely like an offline type of activity?
Yeah, so if I haven't tried it yet, so I wanted to see their past, like this group of students, their past reluctance to do things that I saw as more Cody thing, maybe just want to try the first step. But no, if they let me teach it again, I may have to fight someone for it, because actually a lot of people like teaching this class. I do. The next step would be like those examples I showed. And I would probably have to spend, I would say, I would have to take the part of the class time that we spend working on whiteboards and make that this, I think, for it to be successful, given the small samples I got for the extra credit. So yeah, it would just be, I think there's ways that you could do that so that they're still solving problems. We're just doing it, with more simulation kind of things. But yeah, I don't think we'll have to do this 3-way split again. I think that we're done with that. That was just a one-off for tell about the bio folks. Yeah, I see another question.
I just wonder when you talk about Excel coding, when in the lab, do you require students also use Excel?
Yeah, so
Okay.
there's no coding or simulation in the labs. That's a long time dream of mine, but I have to cut other stuff and I haven't figured out what. But yeah, they use Excel in the labs. That's where they're supposed to put all their data. That's where they calculate like averages and standard deviations, and that's where they have to plot like their whatever they picked for their independent variable versus the set dependent variable. So they have to do all that in Excel. So they build their Excel basics, I would say, pretty fast the first couple of weeks.
So that also requires use of Excel functions, right?
Some of them, yeah, like we show them that you can do that. It's really surprising to me how many of them, like just from the lab perspective, like we'll say like, here, look, there's a function that will calculate the standard deviation for you. And I will still have students with their calculator after they found the average with their calculator going by hand to find differences with each of the values. And like, yeah, no, they should be, the resources are there to know how to do that, but they had not, no. I don't know if I'm answering your question.
Yeah,
I'm sorry.
If I may, can I ask what's required in your lab or physics, general physics lab for us?
Yeah, that's like a whole big thing. So what we do in our labs is that they're given, I guess to give you an example, we have a large collection of things that they can drop, all kinds of things. And their goal is to be able to figure out what things affect time to fall, such that they can distinguish between it either just being like what you would expect, like the typical, I always forget, square root 2g over h, or is it h over 2g? I forget, right? But like just that standard formula, or if it's something else. And if it's something else, they have to be able to show us what form that is, at least a version of it. And they have to be able to distinguish between those. So like they can't have overlaps between where they would expect it. It's pretty I like the goal for me and with the labs was, can you make accurate predictions and separate out the predictions from one theory from what you would get from another theory? And if you can do that, then you can say, okay, this one doesn't make sense. Like, oh, if I've got this, like fairly dense, fairly compact object, I should expect that to fall. But if I drop something that maybe isn't like that, okay, then that won't fall according to this equation that I've got. That was the goal. I would say they get pretty good at certain steps, but the big overall, oh, this is what we're doing thinking, I don't think we're there yet. Yeah.
Thank you. That's interesting.
Thanks.
Jennifer, I think this is fabulous, actually. And I think, even though I know you've emphasized you haven't done a research project, and this is the first semester you've done this, I think you do have some anecdotal observations you've shown that for lack of a better term, a computational thinking approach, I think has actually helped in the students doing analytical problems. And so in that sense, I think it's very valuable for this level of students. And I'm just wondering, have any of the students themselves offered any feedback? The ones that maybe have taken it seriously, or for instance, the ones that got into the basketball thing. Have they offered any feedback that now they wouldn't know, of course, if they understand physics better as a result of this. I'm just wondering if there's any feedback at all. Because I think this would be effective across the board in introductory physics in general.
I will say I never used the phrase coding at all until we got to the basketball simulation. I never said anything about coding. I always emphasize it as basically a calculator, like you're building yourself this calculator. And I kind of did that intentionally because I've noticed in the past just saying simulations, computer simulations, like just like terror, you know, like, so I was a little nervous trying the basketball simulation kind of thing, because, and that's part of why I did it as extra credit and like short period, just try this. So students have not commented to me about whether or not the Excel sheets are useful. I'm looking forward to the end of term survey things, because they let you know, like if you have like 300 students, they just let you know everything. So we'll see if that shows up at all. Like I said, I didn't plan this as research, so I didn't think of like, here's the things I should ask at the beginning and at the end to know. And we're just like, oh, this will be fun to try. Yeah, I'm hopeful to see kind of if they list that as something that they saw as beneficial. Like I said, the people who tried the basketball sim, like I just got like, we have a Discord that's available for the labs so that students can ask questions, and I sometimes have students just message me on that. And I had somebody just direct message, they're like, this is the coolest thing, I love this, I want to do more of this. And I was like, I'll try to think of something, because like the Excel stuff
actually wanted to be in physics class.
Yeah, right, like maybe. And I should say I was probably too pessimistic about their viewpoint. They a lot of them did start off with positive, like I asked their introduction posts, like they were supposed to talk about themselves and what they like doing. And I had a not insignificant number of them say at the beginning, like, I'm interested to try this, meaning the class. So they're not, I think they're probably not as pessimistic about math and physics as perhaps my probably misguided perception is, but certainly the trying to get the basketball into the hoop. It's like basically Angry Birds. And we know that worked, like whatever that was 10 years ago. So. Concept before name. I've heard of that author. I need to go concept before name. I see what you're saying, I think. Okay. Sorry, write that down. Find it.
Jennifer, I think you kind of alluded to like trying this or maybe something similar in your like a survey, like astronomy classes. Is that right? What was it, kind of like the same type of activity?
Yeah.
Okay.
I got really into Google Colab notebooks a while ago, because I've taught like our computational, like we're trying to make this class that's just like getting into computational physics, and I got to teach that once, and I was like, well, this is so much fun, and I use Google Colab books for it. And so then I was like, well, I gotta try this for my introductory astronomy. So what I wanted there is I wanted us to build up from projectile motion into orbits, and like start to see pieces of like how these things work. And we got to projectile motion, and just that was enough through the Python notebooks. Just that, like I could tell they wanted to do it, and they said stuff like, this is cool, but I'm not smart enough to do this. Like I can't do this. And some of that may be that they don't, and students have told me this, because I've tried to add math in my introductory astronomy classes, and it's not that they aren't capable, I don't think, of doing the math, because I've tested them on math questions. They can do it. They aren't there to do that for that class. So I might try the Excel thing again, but I think coming into the physics classes, even at the very like introductory level, they know there's going to be math. But when it comes to astronomy, I think they have a different perception. And they'll tell me this. They're like, I specifically took this so I could avoid math. I just want to talk about pretty cool pictures. And I'm like, I'm sorry, there's math. So I think the Python, but I also think that their expectations. So I want to try again. I think because in that case I was having them like fill, like I did with the basketball sim, I was having them predict things from other information, right? Like here's G and here's how you saw for velocity and position. There's probably a better way of doing that. I don't think this Excel thing would probably work for the survey intro courses, because the ones I see really just don't like that I'm asking them to do math. From what I've seen, I've tried for years. They don't like. Yeah. another. Someone taught they were not smart enough. Yeah, yeah. Take the web v Python from Linux Glow script to body. Yeah, so I've mentioned Sarah Rush, and she has an undergraduate who's working with her, and they're trying to develop some visual Python stuff. They've got the projectile motion one, where students have to like fill in their own little pieces, and then it makes the night. So I may just ask to borrow that and maybe try. Maybe the visual Python will be the, yeah. But yeah, it's not even smart enough. Like they'll tell me, like, as I've asked them, I have this whole survey for the math and astro, and I'll ask them like how they feel. And a lot of them will say, I'm great at it, I just don't like it. So it's not even just always like that they can't do math. It's like, they're just like, why would I spend my time doing this? I just want to look at cool pictures instead in my astro course. Not all of them, but yeah, there's some of them like that.
Hey, that was really awesome stuff. I really appreciate it. Adam from University of Central Florida. I'm curious, right? In implementing, new curriculum or pedagogy reforms, right? Like we each, I think, it takes a while before we finally decide, okay, this is the course or this is the semester where I'm going to try this thing out. What do you remember? What it was that tipped you this time for this, Excel calculator technique?
So I haven't taught this class since 2014. And I taught that during the summer. And I will say, I thought I had reached perfection then, because I designed the whole course off of this video game called The Legend of Zelda. I don't know if you all have ever heard this, but you don't understand, like I was so ecstatic, and I think it only worked because I had small scale, but I had everything set up so that everything was a bad guy. And just like in video game, you could have second chances, and I tied like attendance points to whether or not they'd gotten the master sword. And like, I perfectly motivated it to the point where at the end, these students, like I had students who were like, because they'd already gotten the master sword or whatever, how I describe it. So they didn't have to come to class, and like, I'm still coming to class because this is useful. And I'm like, well, I can never do better than this. But so I didn't get to teach it for a long time. And in the interim, I was doing a lot of trying to get the astronomy students to do math, and hearing mostly Sarah tell me like, why won't they do these steps? Why won't they do these problem solving steps? Why can't I get them to do the problem solving step for like several years in the interim? And so I was like, how can I get them to do this? And so they said, do you want to teach it this spring? And I said, no, because that's a lot of students. And they said, well, no one else can do it. And I said, okay, great, I'm going to do it. And it was mostly just that. Like, I knew Sarah kept suffering all the pain of them just not following all the steps. And this was just, I thought, I can't do my cool thing that counted up attendance because there's like 300 of them. Maybe I can do this. So it's, I don't know why particular. It was just, why not? I'll just try it kind of thing. Yeah. I still wish I could teach the small 114 again with it was so perfect. Like it was, but I had to count attendance for them every single day, and you can't scale that. So there are some things in there. Any type of graphing gets computational students interested in making animations, gets them. Yeah. I think I agree. I think that's part of why they like the basketball simulation, is because they could watch the trajectory change. Yeah, I agree. More of those.
Yeah, like the last time you taught it was like, so like Breath of the Wild has come out since then, so you could have like had a whole new thing about
well and that wouldn't work as well, because with Breath of the Wild they don't like, so it worked out because I did it off of the it's the Link to the Past. No, which one is it? It's not Link to the Past, it's the one that came out for the Nintendo 64 where there's medallions. So I had every one was a medallion. And then you could earn, you could take the red potion version, which would get you some of the points. Like I had a student in that class who wore a Zelda t-shirt every day, and he didn't wear the same t-shirt in the same week. So like but there was like 40 students, and you can get 40 students almost anywhere, right? Like there's just much more you per student. 300, it's just a different, you got to get them to, yeah, so.
Well, it's 8 o'clock. Are there anyone else have any other questions before we maybe close this webinar up?
Gabriela, that's a good idea about attendance.
Oh yeah. Well, let's thank Jennifer again for her, I think very engaging talk. And yeah, I guess it's a quick turnaround till our next webinar. I don't think we have a time yet. Is that right, Kelly?
Yeah,
But
2 weeks hence, same time.
so same time. Okay. So there, so yeah.
Yep,
Yeah.
I will get the link to the report up in case anybody would like to do some perusing before then. You might find it of interest. And don't forget, everyone, these are recorded and posted on the PICUP website. And so you can tell others if you're aware of somebody who's thinking about jumping into this quagmire like Jennifer has done and wants to try something like this, point them to view these and all the ones we've had, back in history. We've got them all posted on the website. So.
Yeah, we don't have a seminar calendar yet because we don't necessarily know that far in advance, but I think that's a good idea for the committee to talk about. Maybe we could put together something for people to subscribe to. So thanks for the suggestion. May not be something we do until after the next round. There's only one event planned, but yeah, tell everyone, tell all your friends and family about next one in 2 weeks. I think it'll be a good talk to kind of wrap up the year. Oh, okay. One day that works for our timeline. Well, thanks everyone for attending. Thanks again, Karen, for getting us started. And yeah, thanks again, Jennifer, for presenting on a really good topic.
Thank you again for inviting me. Thank you, Karen.
Yeah, have a good night, everyone.